So one of my students asked me that he's having some issue in terms of starting with the Kaggle. So let me show you how to run the Kaggle notebooks. So for example, first you need to sign in, create an account and sign in there. And then let's create a notebook. So we click on this, and when we are doing it, we need to select our language. So you can see in here you have the options: accelerator, you have GPU P100 and T4 2. You can select the language. So I will preferentially select the Python. So if you select R, you get this, and if you are selecting Python, you get it. Persistence, variable files, variable you can select, environment, pin to original, or always use the latest environment, whatever you want. So let's see. I use a pin to original. Internet on, add tag, trigger, data sets, or whatever you want. Now the thing is that you can add models. If you click model, you can add different models. Those are available publicly, and you can select them and edit in there. You can go specifically search one. There are a lot of things you can do from there. You can upload your data. For example, you have data, you just drop it in here. You can link them. Or go from the import from the GitHub repository. You can connect it with the GitHub repository, and you can connect with the GitHub repository, and you can bring it from there, or you can remotely connect, or you can import from the cloud storage. There are many things you can do, or the notebook input you can do. There are multiple options those you can do. Also, you can do all things from here. You can start the new notebook, you can import the new book, download notebook, upgrade to cloud, Google Cloud AI notebook, upload your data set, add model, language, Python or R. You can go to the script, notebook or a script, you can share, link to. All these things is exploratory by yourself. So now let's see. We want to show a model, and we want to run a effective, for example, Python based notebook. Let's give it a name, Python single cell RNSIC, or SIC Scanpy. So we select the today's date, January 11th. Okay, it's all right. January 11th, 2024. Let's first, what do you need to do? Do you have any? Are you running in the pip list? We're checking out like is anything in there or not, or just overall. What are the already installed packages in there? You can see there are a good number of them are set in there. But we don't have the package, the Scanpy in here, which we need for this data sets. So what do? We install that. So to install that, first we go to install Scanpy, and for the Scanpy we need Leiden LG. And what do? We get the install comment from here. And it's getting installed. Successfully built in session. So next part, we import our data set. For example, we import NumPy, Pandas, and Scanpy. So it don't take much time. And installed it. Latenwork is installing. And check always in here, is it running or not. So it's installed. Now I can do the restart and run on. Just click on this, it will run on. You can go through these packages. You see, we already installed the Scanpy, which was not in here before. So you don't need to install again. But that's alright. We're just going through this. So then we import the packages, import NumPy as NP, import Pandas as PD, import Scanpy as SC. These are essential packages we need for the single cell RNA-seq data analysis. The next part is, after that installment, we'll be setting up this. So there's a package. Now we need to set up. Okay, we want to install the results in here, the file. And very important thing in there is loading. If you see another video we have how to load the data in a Scanpy, you can get in there. Here is where if you add up the data, you have a link where you have got it. So this is kind of adding up those datas in here. So it's reading your data. And for some reason, it looks like it didn't find it. So we need to solve it first. And I will open. Okay. So we need to solve it. What's the reason it happened? We don't know now. But we can always solve it. We go and look at our data sets. Add data, your data sets. It was Scanpy data sets. So we add up in here. And now this is the data set that we are adding in here. Let's try now. See, now it's successfully loaded. So that's how you do it. If you just use the link, it will never work. So you need to keep the entire data set, proper link, add the data set in here, and then use it. Now we will select our let's check what do we have it in here. Okay, we have number of observations. That's the number of the cells we have. We do a number of variables in there. And then you start looking for the highest number of expressions of gene. And we have this beautiful graph in there. We start the pre-processing first. And after pre-processing, let's look at the data. Copy the data set. selected the mitochondrial genes. Wanted to look at this, and then we thought, okay, this is a real picture, so why don't you just do a next layer of original filtering. So we do this filtering, and now we want to look at again after the filtering, how does it look? And after all these, let's start normalizing our data set. Take the highly variable genes, make a plot of them. Then let's start the principal component analysis. Look at its specific with VRC or something like that. Go for the data. See, significantly reduce the cell number. Let's do the computing of the neighborhood graph. We took the neighborhood graph number 10 and made the neighborhood graph. And then we make the UMAP. Took the so this is kind of a clustering on neighborhood graph is done. And if you want to find, okay, I want to find the marker genes, you will use these. You want to plot the marker genes within your list. You can always do this. You can make the Boolean plot of whatever you want. Compare them as required. Based on the gene expressions, you can cluster them, name the cell types, and you can see in here those cell types. We can also make the dot plot if you want, or you want, okay, I don't like the dot plot, I want only the Boolean plot. So that's it. So make the stacked Boolean plot. You can do hundreds of these things. I don't want to go in there, but this is the overall view. And how you want to do, you can save it always. Let's name this like practice or tutorial. You want to save this, okay, you always can save it, version 1. You can do the FC in accelerator sessions, okay. Now you want to, okay, I want to share it also. So you just make it public, search your collaborator. For example, you said, okay, I want to share with one of the people in here. You just write their People has interesting name, just write their name and you will find it. So you just share it publicly, or if you want to, okay, I want to connect it with the GitHub. So what you do, you join here and do the link to GitHub, and GitHub successfully linked. Save it, share it, and you are done. You can always use this. The Kaggle is a fantastic facility. If you want, okay, I want to use the any triggers in here, or I want to use the GPO or something like that, you can always select from here. As I have shown you earlier, there are lots of options those you can always do. You can do some adding, many things you can done. So I would leave it up to you, and this is the basic demonstration for someone who asked right now. I hope all you all are good. Thank you so much. Any problem, anytime, just give me a message. I'll be there to help you. Good luck.